Hello viewers, in today's session we are going to discuss an important problem from a Dirac delta function, and in this class we are going to find out the Fourier transform of delta prime of t minus pi by 2. So here this capital F denotes the Fourier transform and delta prime denotes the first derivative of delta function, right? So here to get the value of Fourier transform of delta prime of t minus pi by 2, we have to make use of the definition of Fourier transform, right? Now the definition of Fourier transform goes like this. If we have a function say f of t, then the Fourier transform of f of t is defined as 1 over square root of 2 pi, and here we have the integral from minus infinity to infinity e raised to I s times t, and then here we have f of t and dt. So this is the definition of Fourier transform of f of t. So now let us take this function f of t as delta prime of t minus pi by 2, so that the Fourier transform of delta prime of t minus pi by 2 is given by substituting the value of f of t. In this integral, we have 1 over square root of 2 pi, then minus infinity to infinity e raised to is times t, and here f of t is delta prime and t minus pi by 2, and here we have dt, right? So now our aim is to find out the value of this integral, right? And to get the value of this integral, we are going to make use of an important property of derivatives of Dirac delta function, right? So we know that the integral that is minus infinity to infinity, and if we have a function say g of say t, and here we have the nth derivative of delta function, and we have t minus a dt, then the value of this integral is given by minus 1 raised to n, and then we have the nth derivative of this function g of t, and here we write that is n, and here we write a, right? So the nth derivative of g of t is evaluated at this point, that is t is equal to a. So this is an important property of Dirac delta function. So here n denotes the nth derivative, right? And we have minus 1 raised to n, and the nth derivative of g of t is evaluated at this point, that is t is equal to a. So let us take this integral, right? So here if we compare this integral with this one, then our function g of t is given as e raised to I s times t, right? And here we have delta prime, so it implies that the first derivative of delta function is involved. So the value of n should be equal to 1, because the first derivative is involved, and here the value of a is equal to pi by 2. So now let us find out the first derivative of g of t, because here if we write this integral as minus infinity to infinity e raised to is times t delta prime of t minus pi by 2 dt is equal to minus 1 raised to n. So the value of n is 1, and here we have g of 1, and the value of a is pi by 2, right? So here we have minus 1 raised to 1, that is simply a minus, and here we have g dash or g prime at this point, that is pi by 2. So let us differentiate g of t with respect to t. So g prime of t is equal to d by dt of e raised to I times s times t, and the derivative of e raised to I times s times t is simply e raised to I s times t, and here we have by chain rule the derivative of I times s times t, that is simply is, where I is the complex number which is known as iota, and I square is equal to minus 1. So, right, so we have is and e raised to is times t. So now if we take t is equal to pi by 2, then we have a g prime of pi by 2 is equal to is and e raised to is, and here we have pi by 2. So the value of g prime of pi by 2 is given by this expression. So now the Fourier transform of delta prime of t minus pi by 2 is given by 1 over square root of 2 pi, and the value of g prime of pi by 2 is given by this expression. So this integral is now equal to, here we have a negative sign, and then we have is and e raised to is pi by 2. So we can also write this expression as minus 1 over square root of 2 pi. Then we have is e raised to is pi by 2. So this is the required Fourier transform of delta prime of t minus pi by 2.